I am walking through my theory quiz 1 right now. So, for this first question, where W has either the substring AAB or BBA or both, um, I realized that I could do this with just the union of any of those two strings. So I made two DFAs which accept it, and then I kind of use that union technique that we learned. Um, so for this first one containing AAB, you can see how AAB would take you to that final state. And if you have any B's to begin with, you'd kind of have to loop back here. Or if you even got a B after having this first A, you'd have to loop back here. And you can actually have as many A's as you want, because a substring like A, then B would work. And then you can stay here forever with just A and B to take you to that final state. And then the same thing here for my DFA for BBA is pretty much the exact same thing, but with the A's and B's switched. So you can go BBA final, or like BABA, BBBBA, ABAB, and you can get to the final. You can sort of see how that works. So that's cool. Anyways, for the second one, we want to contain at least one double zero, but no double ones. So to begin with, I have this double zero, which will take you to the final state, and that totally works. You can also go like 1, 0, 0, and that works. So you can sort of think of this Q1 as a 0 state and this Q5 as a 1 state before you ever get that double zero. Because if you have that 0 after the 0 state, you're in the accept state, but if you have a 1 after the 1 state, then you've kind of terminated and you can't go any further. And then once you've gotten those double zeros, you still need to check to make sure that you haven't gotten the double one. So you can stay at this 0 state just going over and over again. But if you do get a 1, it's not a big deal, because this is still a final state, and as long as you have a 0 after that, or there's nothing after that, you're still in one of these two accept states. But if you do have another 1, then you're terminated here. And you can't get anywhere from that because you have a double 1, just like up here. So there's that one. And here I picked this DFA to regular expression conversion, just the part A. So here I have it written out, but I added the start and final states with those epsilon transitions. Just the same thing. So to remove Q0, first what we look at is what passes through it. So we have from start to Q0 to Q1. Then we also have from Q2 to Q0 to Q1. So those are the two things we need to remove. For this first one, you can see how it's empty string, 0 star, 1. And that's it. And for this other one, you can go 0, 0 star, 1. Or you could just take this one. So now that we have both of those regular expressions written out, we can get rid of 0, replace S to Q1 with this regex, and then Q2 to Q1 with this regular expression. And now we want to get rid of Q1, so we do the same thing from S to Q2 to Q2. S to Q1 to Q2. We want to remove that one, so that's 0 star 1, 1 star, 0. And then for this one, where you go Q2, Q1, Q2, we do this regular expression, 1 star, 0. And that's it. So now we can remove Q1 and replace S to Q2 with what we just created here. And then we create a self loop from Q2 to Q2 with what we created here. And we can now get rid of this Q2 state. We're so close, we just go from S to Q2 to the final state, which you can see is this regular expression with this regular expression starred, and then the empty string. So that's the regular expression right there. Not going to say it, because it'd probably mess up somewhere, but it's the final thing. These are just the same thing, I just redrew it. And that's that. I did not do this one, but we can get it. Okay, I had to cut, I realized I made a quick mistake in this, but I'll get on to it. We have a proof by construction, where if we construct a DFA that accepts the prefix of L, then we know that the regular languages are closed under prefix, where L is just any language. Because if we have a DFA, then it's a regular language. So let's just consider the DFA for L, which is just the definition. So just this 5 tuple. So what we want to look at specifically is F, the set of final states. Now, if we can replace F with F sub P, where F sub P includes all of the states that were already in F, and every state Q in Q, such that you can get from this state Q through the other states using the transitions from delta to any of the final states in F. Then we have a DFA that defines the prefixes of L. And that construction would be this specifically, where all we did was replace F with F sub P. So that's a proof, and we just know that because if we have a string X that can reach that state Q, and then you can have another string Y that uses those delta transitions to go anywhere through Q, but as long as it can reach F somehow using Y, which would be anything, then that string X is a prefix. And that's pretty much what this specific definition is saying. So yeah, that's the proof by construction.